Hello. So today, for my problem-solving video, I actually chose Algebra 2 as my course. The reason I picked Algebra 2 is it's actually the bulk of my teaching load in the fall. We have looped classes, so 9th and 10th grade are together each year, and so I know that next year I teach Algebra 2 to 9th and 10th graders. I also know that next year's 9th and 10th graders are also going to be very low academically. They have a lot of holes in their understanding. They don't perform well on standardized testing. So I know that that's important, and that's something that I'm going to really have to focus on. One of the main things I feel from Algebra 2 is factoring polynomials, specifically quadratics and solving quadratics. And that's always something that I felt I could do a better job with. I spend a lot of time on it, but I think maybe the problem that a lot of my students have, especially when they have to write an equation and they have roots or a solution, is that our textbook jumps too quickly. So here it shows the FOIL method of factoring polynomials. And we talk about FOIL, first, outside, inner, last. And we do a bunch of different examples. But then the first problem they get is then now write a quadratic equation in standard form with these as roots. And they don't explain why these roots or what we have to do to solve to get our roots or what we have to do or how we started. It's basically, okay, so this is how we started, and that's how I've done it for years. And a lot of times students have an issue with it, and they don't quite understand why it happens and what they have to do. So instead of this year just saying, okay, so we start with x minus 1/3 or negative 1/3 times x minus 6, and go from here to FOIL it out. Instead, I have an activity that I think is a really good one. So the alternative activity that I've found was actually one of the challenge problems, or one of the open-ended kind of challenge problems that they have in the back of this section. And I thought it was really good, and most of the time, we skip kind of those, or students choose not to do those when they're studying for a test. But I thought it's a really good one in that we can kind of change it a little bit and manipulate it a little bit so that students can actually see maybe the difference and why we have to do something. So here's the activity. It says, choose any two integers, then write the equation in standard form with those roots. How would the equation change if the sign of the roots were switched? Okay? So essentially we're asking students to pick two numbers to be the roots. Okay? And obviously they know if it's a root, it's a solution, it's going to have something to do with x, right? And so x something something. So if we let them pick their numbers in any two integers, obviously they have to know what an integer is, positive or negative whole number. If we let them pick, let's say like negative 3 and 5, right? If I let them pick negative 3 and 5 and they just put the numbers in here, okay, and then we let them write the equation out, okay, they FOIL it out, okay, because they know what FOIL is, we just explained what it is, okay, they end up getting this right here as their equation, right? That's what they get. So they think their roots of negative 3 and 5 should end up with this equation, right? Then it says, how would the equation change if the signs of the roots were switched? So for example, now instead of negative 3 and 5, they said, okay, well, we got to have 3 and negative 5. What happens to that then, right? So they write out their equation, okay? And they would have, plus 3 minus 5 right here. And when they factor that out, or FOIL it out, x squared, then they get minus 2x, and then they get minus 15. And so they get two different equations, and then we kind of stop and maybe ask them, okay, so how is the equation changed? Like, what is the difference, right? X squared and negative 15, x squared and negative 15 are both the same. The only difference is this part right here, the plus 2x or minus 2x. And so we would say, okay, well, which one is the right answer? And, there might be a good debate in class about, okay, is it, the positive 2x, is it the negative 2x? So then we get to this part of the activity, and this is what I think is a little bit different. It's something that I added from the question that was in the back of the book. It says, now graph both equations and decide which gave you the correct or original roots and why. So what we would do is we would actually have them go either to their graphing calculator or go to decimals, and we'd have them start graphing both equations. And so I would, okay, so for the first one, it would be, x squared plus 2x, and then minus 15. Okay, and when I graph that, then my roots are -5 and 3. Okay, so then I'd graph the other way, and I'd say, okay, well, x squared minus 2x minus 15. And so when I graph that, okay, then for that one, I get the roots of -3 and 5. So which were my two original roots? Okay, so if we go back to the problem, the original two roots were -3 and 5. So why is it if I have -3 and 5, I get this equation right here? What is it that we did that is different? And what they would see is that this part right here is what's different. And so instead of just putting -3 in and +5 like it did originally and got plus 2x, what they would see is that it actually, the sign has to almost be the opposite, right? And so how do we teach kids how to do that? So then it would come back to this problem, and we'd say, okay, so if the roots are -1/3 and 6, when I have my factors that I have to FOIL, I really have to look at them as the opposite symbol, which is a +1/3 and a -6. And why is that? The reason that is because we have to have the form of x minus my root times x minus my root. And then again we can explain, well, why is it minus? Because when we end up factoring to solve, we're going to want x minus r equals something, okay? And so then to solve it, we would just add, and we'd get x equals my root, okay? So that's essentially the activity is designed to help kids find out this right here on their own without us explicitly saying that. And hopefully that way, if they do an activity like that, they'll remember it a lot better. Because most of the time when we start doing problems then, where you're writing sentences, this right here is not inherent to kids. They have a hard time remembering that, and they just want to put the roots back in. But if we do an activity where they have to actually look at that and solve it themselves, we can create, hopefully, that trigger in their brain that they can do that. So the last part of this question is, what do you think is important when writing quadratic equations from roots? And I think that what we want students right here is to get to the point where they understand that when we're writing roots, it has to be x minus the root versus x plus the root. And I think that will really help our students in